Every second breath you take originates from a vast, unseen ocean factory, producing vital oxygen. This sprawling aquatic ecosystem, covering 70% of our planet, directly governs global climate patterns. Yet beneath its shimmering surface, an accelerating transformation threatens this life-sustaining marine realm. We are witnessing a silent, profound shift in the very chemistry of our world's oceans. For millennia, the oceans have meticulously regulated atmospheric carbon dioxide, absorbing enormous quantities. This natural process, crucial for maintaining Earth's stable climate, relies on a delicate biological and chemical balance. Microscopic phytoplankton, the ocean's invisible forests, capture carbon and form the base of marine food chains. Imagine these tiny organisms as the tireless lungs of our planet, constantly working to sustain all life. Countless marine species, from vibrant coral reefs to majestic whales, depend on these stable conditions for survival. Their intricate relationships create complex ecosystems, supporting biodiversity unparalleled across Earth's landscapes. The health of these underwater cities directly impacts coastal communities and billions of people globally. You rely on these vibrant ecosystems for food security, clean air, and critical storm protection. Understanding their resilience and their vulnerabilities is paramount for our collective future. This intricate oceanic web has sustained life for eons, but its current stability is rapidly eroding. What happens when the foundational elements of this immense system begin to destabilize profoundly? The primary driver of this destabilization is the unprecedented increase of carbon dioxide in the atmosphere. Oceans absorb about a quarter of the carbon dioxide released by human activities each year. This absorption prevents even more severe atmospheric warming, essentially buffering our planet from extreme changes. However, this protective absorption comes at a significant cost to the marine environment itself. When carbon dioxide dissolves in seawater, it initiates a series of chemical reactions, increasing ocean acidity. Scientists explain this process as oceanic chemistry, fundamentally shifting at an alarming, accelerating rate. Imagine pouring a mild acid into a fish tank. The effects might not be immediately visible, but they are profound. This acidification makes it harder for shell-forming organisms like corals, oysters, and tiny plankton to build their structures. Their shells and skeletons, vital for survival, literally begin to dissolve or struggle to form properly. But this delicate balance is now facing an unprecedented, silent threat, altering the very bedrock of marine life. Beyond chemistry, warming ocean temperatures compound these issues, stressing marine life further. Coral reefs, often called rainforests of the sea, are particularly vulnerable to even slight temperature increases. These vibrant biodiversity hotspots experience coral bleaching, where they expel the algae living in their tissues. This expulsion turns the corals stark white, leaving them vulnerable to disease and eventual death. Wait until you hear what comes next, as the impacts are far more widespread than just a few species. Researchers have observed that warmer waters also disrupt marine species migration patterns and breeding cycles. Fish populations shift towards cooler poles, altering long-established predator-prey dynamics in familiar habitats. This relocation creates new pressures on ecosystems, as species compete for dwindling resources in new territories. Furthermore, less oxygen dissolves into warmer water, creating expanding dead zones where most marine life cannot survive. These deoxygenated areas are growing globally, stifling the vibrant life that once thrived there. And then something unexpected happened. These changes are accelerating faster than scientists initially predicted. The combined stress of acidification, warming, and deoxygenation creates a devastating triple threat. Tiny pteropods, crucial food sources for salmon and whales, become severely impacted by dissolving shells. Their compromised existence sends shockwaves up the food chain, affecting commercially important fish stocks. Marine experts highlight how these subtle shifts erode the ocean's capacity to regulate our planet. The ocean's ability to act as Earth's great climate moderator is slowly but surely diminishing. But what happens when these fundamental building blocks begin to crumble, altering the ocean's very fabric? The consequences of these changes are profoundly felt across every level of the marine ecosystem. Coastal communities, particularly those reliant on fisheries, face severe economic instability and food insecurity. Oyster farms, vital for local economies, struggle with larval mortality due to increased water acidity. Coral reef degradation directly impacts tourism, a primary source of income for many island nations. Moreover, healthy reefs provide natural barriers against powerful storms and coastal erosion, protecting human infrastructure. Their loss exposes shorelines to the full destructive force of rising sea levels, and intense weather events. The vibrant tapestry of marine biodiversity, built over millions of years, is now rapidly unraveling. Many iconic species, from sea turtles to specific fish, face increasing threats to their long-term survival. Our ability to discover new marine medicines or biotechnologies significantly diminishes as species disappear. Expert oceanographers emphasize that a thriving ocean is intrinsically linked to a thriving human civilization. You are directly connected to the health of the oceans, even if you live far from the coast. This crisis is not just an environmental issue. It represents a fundamental threat to global stability and human well-being. The cascading effects touch everything from weather patterns to the very air we breathe and food we eat. We are collectively altering an ancient, complex system with consequences we are only beginning to comprehend fully. Protecting our oceans demands urgent, concerted global action to reduce carbon emissions significantly. Supporting sustainable fishing practices and marine protected areas also offers critical hope for recovery. Our shared future depends on restoring the health and resilience of these magnificent, life-giving waters. If you found this glimpse into the ocean's struggles compelling, subscribe for more vital stories and share your thoughts below.